Yes, welcome back from JUICE. So we were doing example 4, and example 4 we are told element X is found in period 3 and group 4 of the periodic table. It consists of two isotopes, X28 and XQ. A sample of X was found to consist of 90% of X28. So we have two isotopes, X28 and XQ and XQ. Now, so then we're told a sample of X was found to consist of 90% X28. If the relative atomic mass of X is 28.3, work out the number of neutrons in XQ. Now, if this is 90% and the two are supposed to form 100%, so this one will be 10%. Now, we are given the relative atomic mass, so we know that the relative atomic mass will be mass number times the percentage abundance plus mass number of the second isotope is Q times the percentage abundance. This one you divide by 100. But are we given the relative atomic mass? Yes. The relative atomic mass is 28.3. So 28.3 is equal to 28 times 90 plus Q times 10 over 100. So now, to do away with this 100, we multiply this side by 100 and this side also by 100. So that this one will be 2830 is equal to this 100 will cancel that 100. So it remains with 28 times 90, which is 2520 plus Q times 10 is 10Q. Now we will have 2830 minus, bring this on this side, 2520 is equal to 10Q. So 2830 minus 2520 should give us 310, which is equal to 10Q. So over 10, Q is equal to 31. So the mass number of Q is 31. Now remember what we have learned. Last time, that when we are writing an element like element X, up here we write the mass number. So Q is the mass number and Q is 31. So mass number is 31. Now this element, we are told that this element is found in period 3. So the element is in period 3 and it is in group 4. The element is also in group 4. No, later we'll learn the periodic table where we know what period is and what group is. So it is in group 4, period 3. Meaning this element has electron arrangement of 2, 8, 4. Period 1, 2, 3, group 4. So what is the atomic number of this element? The atomic number of this element is 2 plus 8 plus 4, which is what? Which is 14. So The atomic number is 14. So if the atomic number is 14, then we know that mass number, come back here, because we are through that. We know that mass number is equal to protons plus neutrons. Mass number is 31. Protons is equal to atomic number. Atomic number is 14. So protons are also 14. This one plus neutrons. So neutrons is 31 minus 14. Meaning neutrons will be 17. Because 17 plus 14, that is 31. So that is the number of neutrons in that element. That is how you do such a question. The next example is number 5. Next example is number 5. So for question 5, an element X has an atomic number of 12 and a relative atomic mass of 24.3. It consists of 3 isotopes of mass numbers 24, 25, and 26. What is the mass number of the most abundant isotope? Now, this element consists of 3 isotopes. That is 24, 25, and 26. So we are going to have 3 isotopes of X. 3 isotopes of X. We have X 24, X 25, and X 26. Yes. Still, we can also write them as X 24, X 25, X 26. Now, an element X has an atomic number of 12. Same atomic number, different mass numbers. Those are isotopes. Then the relative atomic mass of X is 24.3. 24, the relative atomic mass of X is 24.3. Now, if the relative atomic mass of X is 24.3, relative atomic mass is 24.3. I want us to use chlorine. Now, if you look at chlorine, we have chlorine 35 and chlorine 37. Chlorine 35, the atomic number of chlorine is 17. Chlorine 35 normally makes up 75%. Chlorine 37, this 37, normally forms only 25%. Meaning, if you collect a gas, if you are preparing a gas, like that, and that gas is chlorine gas, inside this chlorine gas, it will be made up of 75% chlorine 35. And the remaining 25% will be chlorine 37. That's what we need. So, let's continue. Now, the relative atomic mass of chlorine is 35.5. Now, this 35.5, it is closer to this chlorine 35. It is not close to chlorine 37, this mass. So we say the relative atomic mass is always closer to the mass number of the most abundant isotope. These are the percentage abundance. This one is more abundant, higher percentage. This one is less or least abundant. Most abundant, large percentage. Less abundant. So, there's one concept here which is very important. The relative atomic mass is closer to the mass number of the more abundant isotope. This relative atomic mass should be closer to the one which is more abundant. It can either be closer to 24, closer to 25, closer to 26, but it must be closer to the mass number of the most abundant isotope. And look at this question, that what is the mass number of the most abundant isotope? So the most abundant here must be closer to that. So 24.3 is not closer to 26, so it is not this. 24.3 is not closer to 25, so it is not this. 24 is much closer to 24. So in that case, we settle for the most abundant isotope. So the mass number, that is part A, the mass number of the most abundant isotope is 24. So the answer there is 24. That is part A. And we move to part B. Part B, we are told give a reason for your answer. So part B will say the mass number of the most abundant isotope is closer to the mass number of the most abundant isotope. Or we put it this way, the mass number is the mass number of the most abundant isotope. The most abundant isotope is closer to the relative atomic mass. So the mass number of the most abundant isotope is closer to the relative atomic mass. That is the reason why the mass number of the most abundant isotope is closer to the relative atomic mass. So this is the most abundant. This is the one which has got the highest percentage. Then the next question we have, how many neutrons does the nucleus, how many neutrons does the nucleus of the isotope with a mass number of 20 contain? That is C. Mass number of 20 or mass number of 26 contain. So we have this isotope with a mass number of 26. This one here. And atomic number of 12. So they want how many neutrons? So we know that mass number is equal to protons plus neutrons. Mass number is 26. Protons are 12 plus neutrons. So neutrons will be 26 minus 12. Neutrons will be 14. So this isotope has 14 neutrons. We have done that. What is the oxidation number of the ion formed by Z? Now, later, because we are going to cover that, that's a question that you can only cover after you've done the next part. So you can try number 6. You can try question 6, telling us that potassium is isotopic and has a relative atomic mass of 39.5. Work out the percentage abundance of each isotope in a given sample of potassium which was found to contain 3 isotopes of potassium 39, potassium 40, and potassium 38, with the abundance of potassium 38 being 0.01%. Then we also try number 7. An atom P contains 90% of isotope and 10% of another isotope. Calculate the relative atomic mass of P. Then number 8. An element M has 2 isotopes, M63 and M65. The relative atomic mass of the naturally occurring M is 63.55. Calculate the percentage of each isotope. Then number 9. An element Z has 2 isotopes with relative abundance of 65% and 35%. If the mass number of the 2 isotopes is A and 31 respectively, find the mass number represented by A given the relative atomic mass of element Z is 30. Number 10. Determine the relative atomic mass of element K whose isotopic mixture occur in the proportions sorry, that question is incomplete. So that one brings us to the end of this discussion. Try those questions and check if you can work them out. Let us meet next time during our next lesson.